Half a day. In this video, we're going to be going over fractions, particularly covering proper and improper fractions, like and unlike fractions. By the end of this video, you should have a good grasp on converting improper fractions to mixed numbers and vice versa, reducing fractions, and then multiplying and dividing fractions. So let's get to it. First of all, what a fraction is just a part over a whole. Imagine that we have a box, or we'll just say a rectangle. We have this little shape cut into three pieces. Imagine they're equal. So 1/3 of this box, the shaded intersection, is not representing one whole because it's just a portion of the box. It's going to be 1/3 of it. In the same way that if I was to shade in another one, it would be 2/3 of it. So these fractions are just pieces of whole numbers. And fractions, they're in the form a over b, where a is your numerator and b is your denominator. And there are two different forms that it could be in, an improper fraction and a proper fraction. So with a proper fraction, the numerator is less than the denominator. So it represents less than one whole. So for example, we have like 1/2, 3/5, 9/10, right? The top number is less than the bottom number. An improper fraction is a fraction where the numerator exceeds the denominator. So it represents more than one whole. So for this one, we would have like 10/7, 30/29, 3/2. Anything where the top is more than the bottom. Like fractions are fractions with the same denominator. And then for unlike, of course, that's going to be different denominator. So for these ones, we'll have like 1/3 and 2/3 are like fractions. Unlike fractions would be like 2/5 and 3/7. It's important to note that any whole number can actually be written as a fraction, and that's by just putting it over 1. So for example, if we have the number 2, it's the same as 2/1. So in some cases, it may be useful to represent a number as a fraction, and this is how you'll do it, by just placing it over 1. And that's how you'll represent a whole number as a fraction. So we've already introduced improper fractions, and we can see that these are examples of them because the numerator exceeds the denominator. A mixed number is just a whole number with a fraction. So it's the sum of a whole number and a fraction. An example would be like 3.5. We have a whole number and then a fraction attached, so just be 3.5. Okay, so when converting from an improper fraction to a mixed number, there are certain steps to follow. The first one would be to divide the numerator by the denominator. So in this first one, letter A, I'm going to do 9 divided by 7. Of course, only one 7 can go into 9. We have a 1 there. I'll multiply by 7. Subtracting, I'll end up with a remainder of 2. So these things are going to be very important for us. We're going to keep that 1. That's going to be our whole number. Our quotient is our whole number. Our remainder is going to be the numerator of our mixed number. And then our denominator is going to stay the same. Let me just actually write these out. So I'll just say, okay, whole number this becomes the numerator. And we have the same denominator. We'll do the same thing over here on the right side. 62 divided by 8. 62 divided by 8, I know 7 can go into that. We have 56 from there. Subtracting, we're left with 6. Again, we're going to take this first as our whole number, 7. This is important, that's our numerator, 6 over the same denominator, 8. Notice that this is not in simplest form, but we're going to go into reducing fractions later on in this video. And then now we'll go into converting from mixed number to improper. So in order to do this, there are certain steps we're going to take, and this one is actually much easier than the last one. So I'm just going to rewrite this, 2 and 5 over 8. What I'm going to do is take this denominator, multiply it to my whole number, and then add my numerator to that. So again, we have 8 times 2 plus 5, and then we're going to keep our same denominator. This comes out to 16 plus 5 over 8, which is just 21 over 8. Again, we're multiplying this 3 to the 10, adding our numerator, and then keeping our denominator. This is going to be 3 times 10 plus 2. I'm actually going to change these out. I don't know why I put x's. Oh, because I put it in the little thing there. 3 times 10, 8 times 2. Over, same denominator, 30 plus 2 over 3, which is just 32 over 3. So that is converting from mixed number to improper fraction. And I just wanted to state that for the rest of your classes, you're going to be using improper fractions. If there's ever any question, leave your answer in improper fraction. Next, we're going to be going into reducing fractions. So with reducing fractions, we first have to think about equivalent fractions. So it makes sense that, say for example, I have 2 whole bars, and I'll draw them out right here. They both represent 1 whole, but the first one I'll separate into 3 pieces, and the second I'll separate into 6. Okay, and notice that if I was to take 1/3 of the first one, I'm just going to highlight or fill in or shade in, sorry. So this is equal to 1/3. I'm going to fill in the same amount for the second one. And now I have 2 spaces filled in, which is 2/6. And you'll notice that these two have the same value, and that's how why we have equivalent fractions. They're both represent the same amount. When reducing fractions, what we want to do is get it to its simplest form. So we might have an equivalent fraction, but we want to reduce it to its simplest. These two, I would want to give 1/3 instead of 2/6. So now we'll go into reducing some fractions. I have some examples here, a couple. So we have A, we'll do 24 over 42. B, we'll do 49 over 42. Okay, looking at this first one, basically all I do is just think of what numbers can divide both my numerator and denominator. So don't think too hard about what's the biggest number that can divide both, because you can always just keep breaking it down. What you want to do is reduce it, and then if you can reduce it again, reduce it again. There's different ways that people do this. Some people do it by prime factorization, canceling out common factors. But if you can, just reduce it as you go, and then just try to see if there's anything that you can reduce once you have your final answer. And once you can't, then that's the simplest form. So 24 and 42, right off the bat, I can already know that they're both divisible by 2 because they're both even. So that might be where I'm going to start. Divide both by 2. The numerator and the denominator. So I'm left with 12 over 21. Okay, 12 and 21 are both divisible by the number 3. Divide both by 3. And then I'm left with 4 over 7. 4 over 7 have nothing in common besides 1, so that is the simplest form there. 49 and 42, I know both of these are divisible by the number 7. Divide both by 7. I'm left with 7 over 6. And again, these two have nothing in common, so that's the final one. Now we'll look into multiplying fractions. So if you see here, we have the top, we have a over b times c over d. What you're going to do when you're multiplying fractions is you can just multiply your numerators and then multiply your denominators. So my numerators are a and c, a times c over b times d. And if you can reduce it, then reduce it. One thing I want to touch on is our ability to cross cancel. So we're able to cancel out common factors before we even multiply our numbers together. And we'll see this in letter C and D in our example. But let's just do letter A normally. Cross canceling only works when the numbers opposite have common factors. For example, we see here 3 and 7. 3 and 7 have nothing in common. 2 and 5, the ones across, have no common factors. So all I'm going to do is multiply across. 3 times 2 over 5 times 7, which is just 6 over 35. Always check when you give your answer as a fraction. Check if you can reduce it or simplify it in any way. 6 and 35 have no common factor, so that is in its simplest form. 5 times 1 over 12. You'll notice that in the example up in the top where we have a, b, c, and d, I'm given a fraction multiplied to another fraction. So what we want to do is force 5 to be a fraction. And we discussed this earlier. To write a whole number as a fraction, all I'm going to do is make it over 1. Right? And from there, I'm going to multiply. Or first I can see if there's any common factors between the diagonals. 1 and 1, it's the same number, but it's just going to reduce to 1. 5 and 12 have nothing in common. So all I'm going to do is multiply this across. 5 times 1 over 1 times 12. And of course, this is just 5 over 12. For letter C, now we're going to look into how we can use cross-canceling. Letter C, already I can see that 7 and 21, they are both divisible by 7. So what I can do is cancel each of these. I know 21 is just 7 times 3. So this is going to become 3. I'm dividing both by 7. This one on the top becomes a 1. 12 and 4, they're both divisible by 4. I can cancel them. 4 is going to become a 1. 4 divided by 4 is 1. 12 divided by 4 is 3. So these are the new numbers I'm working with. And then from there, I'll do the same. Multiply my numerators. My numerators are now 1 and 1. We have 1 times 1 over 3 times 3, which is just 1 over 9. Here in the top right, we have 4 over 25 times 15 over 8. Again, I want to see where I have something in common. In the diagonals. So 4 and 8, very quick to see. 4 and 8, they're both divisible by 4. Divide both by 4, we end up with 1 and 2. 25 and 15, I can reduce by dividing each of them by 5. Which leaves me 3 and 5. Okay, multiply my numerators. I have 1 times 3 over 5 times 2. And again, you don't actually really need to put this step right here. If you can, just jump straight to 3 over 10. And always check, can I reduce it? No. So just leave it as that. For letter E, what I'm going to do, when you're going to multiply fractions, you want to put it first into improper form first. So I'm going to put a note up here. Put into improper form first if a mixed number. A mixed or whole number. Two and 11 over 12. Again, 11 or 12 times 2, 24 plus 11, we have 35 over 12 times 5 times 1 is 5 plus 3, we have 8 over 5. This one has pretty nice cancellations. 5 and 35 are both divisible by 5, so we'll end up with 1 and 7. 12 and 8 are both divisible by 4. We have 2 and 3, which leaves us with 7 times 2, which is 14, over 3 times 1, which is 3. And this is not reducible. If you were to skip the cancellation step, you would end up with larger numbers in your fraction on the right side, which you then would have to just reduce, right? We'll have to simplify. Since we're canceling first, you'll notice that we're not doing any reducing because we're reducing before we even multiply. And looking at letter F, find 2/3 of 18. If ever you see something like this, find 2/3 of a number, all you're going to do is multiply that number by 2/3. And this works also for like, oh, this is 70%, right? So 70% of 100, you're just going to multiply 70% times 100. So in the same way, I'm going to multiply this 2 over 3 times 18. And I already know I'm going to have to put it in as a proper fraction, improper fraction. So it'll be 18 over 1. If you want, you can reduce it. That 3 and 18 can cancel out and be reduced. I'm actually going to try just multiplying it across first and then reducing after that. Okay, 2 times 18, I end up with 36 over 3. From there, actually, they're both divisible by 3. So I end up with 12 over 1, which is just 12. Notice that it was a tiny bit more difficult just because I was having to multiply larger numbers. Again, that's why this cross-canceling really comes in handy, especially since we're not allowed to use calculators in this, right? What we'll go over last is just dividing fractions. When we're dividing fractions, again, we have another formula that we're going to be using. So if I have A over B divided by C over D, this is very similar to multiplying, but all we're going to do is we're going to think of division as multiplying by a reciprocal. When I say the word reciprocal, it means it's the same fraction but flipped. The reciprocal of 4 over 5 is 5 over 4. Reciprocal. So what we're going to do when we're dividing fractions, we're going to multiply by its reciprocal. And a lot of times people like to say flip and switch. So we're flipping our fraction and then switching it to multiplication. So this is going to be equal to A over B. Now we're multiplying by the reciprocal of the divisor, the one that you're dividing it by. The second one, D over C. Reciprocal of the divisor. And the divisor is that second one. Okay, going straight into an example. 3 over 5 divided by 3 over 7. What I'm going to do is flip that, change it to multiplication. 3 over 5 times the reciprocal, which is 7 over 3. Here, I can either multiply across and then reduce or cancel where I can. I already can see I can cancel these, reduce them to 1. 1 times 7 is 7 over 5. For letter B, in the same way as the other one, we want to convert it to an improper fraction by multiplying, right? Multiply and then add. So 6 times 5, or 5 times 6 is 30. Plus 4, we have 34 over 5. Divided by 10 times 1 is 10 plus 7. We have 17 over 10. Flip it, switch it to multiplication. 34 over 5 stays the same. Times 10 over 17. Cancel where you can. 5 and 10. We have 1 and 2. 34 and 17. These are both divisible by 17. 1 and 2. And you notice that those are big numbers, right? It would have been really hard. Not really hard, but it would have been taken a little time to reduce that if I didn't cancel it first. So we're ending up with 4 over 1, which is just 4. Lastly, for letter C, 7.5, converting that to an improper fraction, we have 2 times 7, which is 14 plus 1. 15 over 2 divided by 1 and 1/2. 2 times 1 is going to be 1, or 2 times 1 is 2, plus 1 is 3 over 2. Multiplied by the reciprocal of that divisor. Cancel where I can. Both of these numbers are divisible by 3. This will become 1. This will become 5. I'm dividing both by 3. 2 and 2 will cancel each other out, so we have 1 and 1. We're left with 5 times 1 over 1, which is just 5. I hope you guys were able to learn something from this video. It was quite a bit. In the next video, we're going to be going over adding and subtracting fractions, as well as applying powers and square roots to fractions. So good luck. Have a good day. I hope we're all trying our best, and I appreciate all your hard work.